Okay, we're going to look at something called the sine rule in trigonometry. It's pretty important, so let's get started. We're going to start off with a proof, and this proof is really pretty easy. You start off with a triangle, A, B, C, and then you drop a perpendicular straight down. That perpendicular will be the height of the triangle. It'll be the height of the triangle. The little side opposite A is right there. The little side opposite B is there. And this whole side down here is called little c. But hey, we've got something here. We know about trigonometry. In this right-angled triangle here, the sine of A is the opposite, which is h, over the hypotenuse, which is b. So the sine of A is h over b. The sine of b is the opposite h over this hypotenuse, which is a. So we've got two ways of getting sine b is h over a, and sine a is h over b. But if we multiply by b, this one, we get h is b sine a. And if we multiply by a here, we get h is a sine b. Now we have two ways of looking at h. Because they're both equal to h, we can let them equal each other. And a sine b equals b sine a. Now we divide both sides by sine A and both sides by sine B, and we end up with the sine rule. A over sine A equals B over sine B. Wow, this is really important. The ratio of a side over the sine of the angle opposite it is equal to the another side over the sine of the angle opposite it. C it will also equal C over sine C. And why that's true, it takes a little bit more thinking. Here it says symmetry, but right here is the core of the sine rule. And let's use it in an example. Remember, you use it when you've got sides and angles that are opposite each other. That's when you use the sine rule. And let's just get started and try to use it. Now, what I thought I would do, I'm going to cover that just for a second now. We've got a triangle here, A, B, C, and you're asked to determine AC here. You're given two angles, and you're given this side 15 meters. Well, we got a little bit of a problem to use the sine rule because we've got a side and we don't know the angle opposite it. But you remember from primary school, remember that the angles in a triangle add up to 180, so if you go 180 minus these two added together, you're going to find that angle A. Well, now we've got angle A. We can get started with the rest of it because we know that's 62 degrees. Now, all we do is we take the thing we don't know, AC, over the sine of 82 equals 15 over the sine of 62 that we just figured out. Well, that's what you do. AC over the sine of 82 equals 15 over the sine of 62. Now multiply both sides by sine 82, so you get 15 sine 82 over the sine of 62. Just put that in your calculator and see if you don't get 16,82 meters, rounded off to the nearest hundred. Now you can use it to find an angle as well. You can use it to find an angle. I'm going to cover this solution here to give you a chance to try this. What if I asked you, here's a triangle ABC. I'm giving AC is 19 centimeters, BC is 15 centimeters, and I asked you to find angle B. Well, you go ahead and try and do it, and you could stop the video, or you can just watch it right now to see how it's done. Well, say we're trying to find angle B. Angle B goes with 19, so that's why I go sine B over 19. And sine 44 goes with 15, opposite 15. Well, that's the main thing here. The only thing that's a little bit different is you multiply by 19, you've got the sine of an angle now. It's this thing, 19 times the sine of 44 over 15 in your calculator. It's a fraction between minus 1 and 1, otherwise it won't work. You've got some fraction in here. But to find the angle, you've got to ask your calculator what angle fits with this ratio here. And you go shift sine of whatever that is, and it'll tell you that angle B is 61,63 degrees. Well, that's the sine rule. I hope that helped.